We will actually send out an email to everyone who registered to let you know when the PowerPoints are posted and if there's any questions, that sort of thing. If you are, excuse me, if you are from USDA, you need no permissions. You can just access it and you can get into the main page. There are some working pages on there within the SharePoint site for various teams, but the main page for this event, for example, and training and other types of things, because we do give a monthly training webinars in conjunction with Esri. So there's we're trying to populate it, lots of stuff on there. We encourage you to use it, but we will send that out. So again, if you're USDA, no problem getting access to it. Okay, with that, we'll go ahead and get started again. Those were really great presentations this morning. Thanks, guys. Very interesting. And we're going to continue that with the next group. The title of this session is called Transforming Geodata to Information to Action. And really what it's about is creating business intelligence for decision making. And USDA is really taking strides in taking that raw geospatial data and turning it into informational or actionable information. We had a little bit of that discussion this morning. There's going to be more of that with the 3 presentations right now. Ken Holman from the Forest Service is going to be talking about the Kenai Peninsula, Alaska, existing vegetation. Next after her will be Lisa Colson from the Foreign Agriculture Service. She's going to be talking about the Global Agriculture and Disaster Assistance Assessment System called GADIS. And our last presentation of this session is from Jim Hipple from the Risk Management Agency, and he'll be talking about enhancing integrity in crop insurance through data mining and analytics. Now, just a reminder, we're going to hold questions to the end. We have mics. Even though it's a small group, I'd appreciate it so that everybody can hear. If you have a question, please bring it to the mic. I'm going to kind of try to pay attention. I've got a handheld. I'll bring it up if you're not comfortable, but we would really appreciate that. And then our 3 presenters will come back and we'll use the mic for response. So with that, Kim, thank you.
Hi, good morning. I'm Kim Homan. I'm a Geospatial Program Manager for Alaska Region Forest Service. And today I'm going to sort of build on the presentations that we heard earlier this morning and talk about how we're using some of this information in Alaska and maybe some of how we're not able to use it. We'll talk about that a little bit too. So where is the Kenai Peninsula? We're in the state of Alaska. It's sort of on the Gulf of Alaska, south of Anchorage. This is a 5.7 million acre area of interest. It encompasses a lot of land ownership. So the Forest Service, the Chugach National Forest, is about 1.5 million acres of this area of interest. So what is an existing vegetation map? Why would we do it? In Alaska, we don't have the same level of information that you have in the lower 48. So we're challenged with imagery that's lower resolution and an older vintage. So we're looking to create a current vegetation map at about the scale of 360 to 100,000. And primarily Landsat. We have some high-resolution orthophotos. We have some other ancillary data sets and elevation data. What is it? We're combining a field data collection with a traditional classification process to locate exactly where the vegetation types are. We really couldn't do this work without our partners. I talked about how Forest Service land was only a piece of this entire area of interest. So we really relied heavily on them. They partnered with us as team members through the whole process. So we had big partnerships inside the Forest Service with state and private and forest health, fire. We partnered really closely with our Geospatial Technology and Application Center in Salt Lake City. They did a lot of the analysis, the really hardcore number crunching. We had Fish and Wildlife Service actually flew some high-resolution resource-based imagery for us for this whole area, or the majority of it. National Park Service contributed data and information, particularly in field data collection with the project they already had on the ground. We worked with the borough, we worked with tribes, we worked with some regional consortiums, all hands, all lands groups, really phenomenal group of people, and coordinating with the state of Alaska's Geospatial Council as well. And inside of our team, we talked about how we engaged our partners at all levels. We also worked with a lot of cross-programmatic folks in wildlife and fire, ecology. We stood up a model about 10 years ago that we've been working with, where we're really, the core team is our ecology staff at all units, so across the forest, to the regional office, and at the district level, and similarly in the geospatial and remote sensing world. But we did incorporate people from all over. They participated in our biweekly meetings. We're really closely attached, and we couldn't have succeeded without that. We also used a lot of what you've seen earlier today as interactive field models and dashboards. My animation, okay. So we used ArcGIS Online. We developed a field survey. I'll show you a little snapshot of that here in a minute. We had some web mapping applications that we relied on heavily, and we used those from the field data collection all the way through the map review, accuracy assessment, all the way to the end to the final products. Our final product is a story map, and we'll take a look at some of that today. So the dashboards were really fun to use as folks were out collecting data in the field. This is Emily Thomas. She's the Fish and Wildlife Service partner out collecting data with the iPad. We were able to see the field data come in, which is really fun to watch. So on the dashboard, as their data were syncing up, we could see it happening, and we could do QA, QC right there on the fly. The ecologists could look at the data and say, I think this one crew is maybe a little off on their species data. We could check back in with them, make any adjustments. And similarly, if we were collecting enough information of different vegetation types. So some adjustments were made along the field season as well, just by having that information right at our ready, which is really, really fun. So the products are, this is the primary product, which is the dominance type map, and you heard Phil talking about land cover mapping. This goes that next level deeper into the specific species and kind of communities that you see. We had tree size, so elevation data I mentioned was incorporated into this. We could take a look at the structure and see how tall the trees were. Tree canopy cover, and tall shrub canopy cover. So shrubs are a really important part of this environment for fire and fuels management, and also for habitat management with moose browse. Bruce mouse, fun. I was going to demo a story map, but I think I'm just going to show you some snapshots instead, so we can kind of take a look at what the final product looks like. The story map, if you haven't been there, the URL is embedded in this presentation, so you'll be able to get to that. It's really scrolly, and you can interact with different pieces and parts. I really encourage you to do that. It's fun to play with. Those first few tabs, you see the tabs kind of highlighted across the top, are really giving you that background information we just talked about, partnerships and methodologies. This next tab goes into the data, which data were used. It highlights each of the data sets. Landsat was used really heavily to do some of the spectral characteristics. The next tab is, well, let me put my glasses on just to be sure I'm reading it right. Modeling units, where we start talking about, we use e-cognition to determine the differences between all of these stacks of images and geospatial data. So this is sort of an object-oriented classification. It's not pixel by pixel based classification. So these units that you see on the far right, the yellow boundaries, are showing you where the imagery is finding like areas, and we'll classify those like areas as opposed to doing each individual pixel. So in the application, this is a slider, a swiper application. You can kind of cruise back and forth and check out what those segments look like on the ground. Just a quick snapshot of our survey. You saw some of this earlier. I think it's really being used a lot in the field to capture data. We had both really descriptive plots where we captured understory information, and then we had observational plots where we're really just looking at that full dominance type. And because I have your attention, I just want to point out one of the challenges we have in our remote offices are issues with our wireless connectivity. So implementing this mobile data collection, putting this power into our field going staff's hands is a little bit impaired by our overall IT infrastructure. Something for us to consider. They did a great job, but it's sometimes a little bit challenging. The next tab over is highlighting our reference data collection. So we had folks out in the field. They collected roughly 800 sites on the ground across the Kenai Peninsula, partners and Forest Service staff. And these are the results of that. We also did some helicopter data collection, and we had legacy data as well that we used in the classification. So we're looking at you can click on all those points and see this is a wet herbaceous area. There's photos that go with each collection. This is a more forested area in the along the coastal rainforest. The final tabs talk about the methodology for the analysis. You can take a look at that. And also the final map tab shows you the interactive map data. So I kind of want to go into this final map a little bit so that you can take a look at it. On the left-hand side, you see the data is available for download. It was really important to us to make the data really accessible for our partners because they played such a huge part in all of the steps along the way. So you can download data straight from there, or you can interact with it in this web map. There's a little button in the web map that you can click. It's a little bit hard to see there, but it makes the map go full screen. So this is an example of how we have been using this information. We had a large fire. A Swan Lake fire was about 100,000 acres last summer. And, my first thought was, oh no, our brand new map just burned up. But it really does set the scene for us to be able to do some analysis along the way of what that looks like. So in the application, you have the ability to add your own local data set. So I just went on ArcGIS Online and searched for the Swan Lake fire perimeter. I was able to find that and bring it into this map. So we're zoomed into that area a little bit. The existing vegetation is going to swipe across. I've added the slider tool, and since we're not doing this live, just to kind of give you that feel of how that works, you can see the, sliding back and forth over. You can zoom way in and look at individual little parcels, and you can still interact with the data to see what kind of data type lives underneath it. The next steps, and our partners and the Forest Service are using this information. We talked a little bit about the fire, so fire and fuels management. We're contributing this new information to land fire. We're doing habitat modeling and management, particularly the state of Alaska's fish and game. You see the collared moose down there. They're trying to assess where the moose habitat are, so they're using this information along with their collar tracks to do some analysis there. Recreation planning, forest planning, climate change and monitoring, and some plant succession modeling. They've had also spruce bark beetle damage in this area, and they're noticing that the vegetation are not coming back as they expected them. So there's been some analysis started there. Did I lose my screen? Did it not go? Okay. And so up next, we're going to continue to do vegetation mapping along the Alaska region. This is the Alaska Region Forest Service. So we have Chugach National Forest, Tongass National Forest. We're doing some work around the Copper River area. We have a really big project going on down there in the south. Let's see if I can use this pointer. On Prince of Wales Island, right about here. We've, working with the state of Alaska and other partners, have also purchased a large LiDAR data set. This is not a common data set in Alaska, unlike Lower 48, but that data is going to help us with the forest structure modeling, so we're doing quite a bit of work there. And then we'll expand over to the east a little bit more with the Ketchikan Ranger District and Misty Fjords National Monument. Go the wrong way. Which way do I point? There we So you can find all this information on our public website. It's all publicly available. You can navigate through the Forest Service Alaska Region website through Plants and Animals. It's easy to find. I wanted to acknowledge Dustin Whitworth's here. He's our remote sensing specialist. He's going to answer all your really hard questions that you ask. I really operate as the project manager and kind of a facilitator for this project. Barb Schrader is our ecologist, regional ecologist, and she does all of the plant classification. She works with all the ecologists across the forests. And then Nathan Pugh is our project manager at GTAC, and really this work is would be really difficult for Alaska Region to do without them, so I appreciate their hard work too. Thank you.
Good morning. I think it's still morning, right? It's been a long 3 days, I think. My name is Lisa Colson. I am a geographer with the Foreign Agricultural Service, so I'd like to invite us to switch gears. We're going to talk about the rest of the world. We've built an application we call the Global Agricultural and Disaster Assessment System. That's kind of a mouthful, so we call it GADIS. We built it not just only to serve our own purposes, but also to serve the public. Next slide. The Foreign Agricultural Service is primarily responsible for overseas activities, market development, trade negotiations, and the collection and analysis of statistics and market information. The division I'm in, we're primarily focused on that last bullet there, and we call ourselves iPad. I'm not referring to those small computer devices that you have. Many of you have. I'm actually referring to the International Production Assessment Division. We have regional commodity analysts who use a wide variety of resources to do their crop assessments, and we utilize that information into our convergence of evidence methodology to provide independent and unbiased estimates of global crop production. This happens on a monthly basis. So our work feeds into 3 different publications or public information sources. One's called the WASDE, and many organizations, agencies of USDA feed into the WASDE. We also have our own publication, the WAP. It's a circular, and the Production, Supply, and Distribution Database, or PS&D Online. We've been feeding into this system of information for many decades. We heavily use GIS to accomplish this mission, and as we all know, computers and IT technology has changed a lot over these years. So several years ago, we started wondering, what if we could do our workflows a little more efficiently? You know, could we be alerted about a problem area more easily? Could we get to some of our routine answers more quickly so that we could spend additional time in challenging areas doing our remote sensing analysis? And so as we were asking ourselves all of these questions, we started exploring them in 2013. And by June of 2018, GADIS became a publicly available and live website. It is a global web GIS system combining comprehensive real-time Earth observation data and tools. It provides users with a highly interactive experience, so you can dive in deep, and you can explore, and you can chart information, and you can look at a large archive. It's very user-friendly. We built this application leveraging cloud technology, and it would not have been possible to build just even 10 years ago. Before I show you a few examples, I'd like to present an analogy, GIS as a dining experience. In the interest of time, I'm going to go quickly to the bottom right-hand corner of your screen. You know, desktop applications like ArcGIS are very powerful. Many of us in this room use it. You got to spend some time finding your data, collecting it all together, figuring out what tools you want to use to run your analysis, and you can look at that information backwards and forwards, just like a fine morsel of analysis. You know, just like those fine dining experiences. In the middle, we have Gaddis, where information is customized and tailored. It's delivered to you as analysis-ready data. It's kind of laid out like a fast casual restaurant, so you can pick and choose between your options. And so you have information in a controlled and tailored way that allows you to save time while maintaining quality. So it's a nice thing that it's not that fast food experience that, many of us are starting to use news agencies that way. It's, quickly getting you to the decisions. And it's not the incredibly intensive ArcGIS experience. It's somewhere in the middle. And so that's GIS as a dining experience. But let me give you a few specific examples. So Gaddis provides you with weather and model data. These data sets are available in the first 3 major categories of the application: weather, vegetation index, and crop conditions. It's a huge archive of information, and every individual data set, if you're talking about rainfall, you'll have a wide variety of variables about that rainfall. So, for example, on the screen here, we have total rainfall, percent normal rainfall, percent precipitation difference. Across the bottom, each of those data sets are rolled into different time periods. You can look at the information weekly, monthly, or decadally. Now, in our context, I don't know if you've come across this term decad before, but we're talking about 10 days at a time. And if you're looking at the weekly data sets, many of the variables are provided that way. You'll get a new piece of information every Monday. In fact, looking at the bottom of the screen, you'll see our time slider. You can scroll through the data sets and see our rich archive of information. Most of those sources go back about 20 years. Some of our sources go back to the 1980s. And then I haven't even started talking about our disaster data yet. That has even a richer archive of information. Speaking of disasters, we're all familiar with the fact that Australia has been having a few problems this year, right? So you can use Gaddis to assess extended dryness. And in this example, you can see in the green, generally where there's agricultural fields. And that's overlaid on top of where it's overlaid on the orange and dark brown, dark red areas. That's where, from the drought severity model, that's where the fields are most affected by the extended dryness, impacting cotton, wheat, and rice in this case. If you're not sure, whenever you're looking at the application, if you're not sure exactly what crops are grown in that region of a country, I invite you to switch to our agricultural lands category. This is where you'll find data sets providing area, yield, and production data on 34 crops worldwide. Each pixel contains these statistics. And so some of our tools allow you to calculate agricultural area affected. And you can just draw a circle, and it's utilizing the statistics from these pixels to give you those summary pieces of information when you choose that option. You can also estimate the potential agricultural acreage damage by a typhoon. For example, we see the hurricane track, as we call it here in the United States, a hurricane. But in that region of the world, they call them typhoons, which is why I'm using this terminology interchangeably. But you can see the typhoon approaching China, and then where that typhoon is located at this particular time period, there's this green and yellow and red wind extents surrounding the typhoon. And so it's those orange and red colors that are the most intense winds. And so you could open up a simple tool called ID and Calculate and draw a box around those orange and red areas to calculate the agricultural area potentially that could be impacted by this typhoon. If you don't want to, have a sloppy estimation like that, you can actually use a polygon and detail the wind layer to create that acreage estimation. And the other thing that's really neat about this example is that all of this disaster data is not something we're downloading. instead, we're connecting to this content live from the Pacific Disaster Center. They cover a wide variety of different types of hazards, and each of the individual hazard events are updated when the official information gets provided to the feed. So it's all in near real time. And this example gives you a sense of what GIS is, right? Using different data layers, seeing where they intersect across the landscape in order to make calculations. It's pretty cool. Of course, I always have to mention satellite imagery. We have 3 different spatial resolutions of imagery that are freely available and completely available for you to explore and investigate. Our satellite imagery, whether you're talking about MODIS, which is provided daily, allows you to have these large geographical, like regional views of crop conditions, or if you need to do field-based analysis, I recommend utilizing Landsat or Sentinel imagery. This imagery is available to you under the Tools menu, called the option Satellite Imagery there. And we put it under the Tools menu because we've also included imagery classification tools. So you can do a supervised or an unsupervised classification. You actually could take your own field data that you've collected and load it into this website in order to do your supervised classification. We support that. Again, we're not downloading any of this satellite imagery. It's available daily and weekly. We are leveraging the much appreciated work of NASA, USGS, the European Copernicus program, and Esri to provide this information. GADIS provides you a variety of geospatial tools, and I wish I had the time to tell you about all of them. So far, I've mentioned that on the far left, about the satellite imagery, the compare and swipe tool, I gave an example of that, and identify and calculate. I also want to briefly mention that under the Analytics tab, there is the ability to chart Earth observation data as well as the commodity statistics. Those commodity statistics come from the database we update called the Production, Supply, and Distribution Database. It's a global database that gets updated monthly. And so you can learn about official US government production and agricultural information from that resource. Moving next to the right where it says share, we have, that's an example of a chart from the database. And under share, we put these 2 little simple tools. One's called export your image, and the other one is bookmark your page. You know, we all know how to do a screen capture from a website. It's easy and simple, but you don't always get the best image from doing that. So we've supported you in the ability to get a higher DPI final map product out of the application if you need it. And this bookmark your page is really cool. You know, many of you are GIS users. You know that you're turning on different layers. You might have been navigating through the time slider, picking out your specific piece of information that you wanted from a specific time period. You might be looking at a specific geographic area. All of that information is somehow like captured by this tool. So you go to the share button and you click on bookmark your page, and it gives you a URL that you can copy and paste into an email and send to your colleague. Now, as I mentioned at the very beginning, our colleagues are in other countries, so this is incredibly helpful for us to be able to do some collaboration and say, hey, take a look at this. Your colleague opens the email, clicks on it, and they look at exactly what you were looking at on your screen. So it's really cool. Like, you don't have to explain to them, go to this geographic region and turn on these layers and so forth and so on. It's a much more efficient way of collaborating with colleagues. And the last thing I want to mention is a tiny little button that might be hard to see on this screen, but in the web application near the common places where you'd zoom in and out of a map, we have this small button that allows you to upload your own shapefile or KML onto the application. So for a lot of people, they might like the weather data, they might like, you know, the temperature information, but they need their own geographic context. We provide cities and roads and a lot of administrative boundaries, but sometimes that information is too generic for your needs. So you could upload your own shapefile and customize your map that way. Oh, I'm running out of time. But I do have to talk about one more tool. I'm sorry, this is just too interesting in my opinion. Not all of us are experts about every country of the world. So if you find yourself needing to learn a little something about another country, you can open this small tool we call Ag Profile, draw a box in the screen within that country, and it'll bring up this summary of regional and country statistics. So you get a land cover map specifically to where you drew your box. You get climatology information that's very specific to that region of where you were investigating. And then you get countrywide information that comes from our production, supply, and distribution database that tells you what crops are grown in that country and the latest information on its area, its production, the imports and exports for that country. And there's a lot of other pieces of information in this agricultural profile, including country crop calendars, which is incredibly important for doing any satellite imagery analysis. You gotta know about the crop season. So we built that all in there. As I've mentioned, Gaddis is a rich visualization tool. It has more than 450 data layers in it. So I wish I could tell you about all of them. But I do want to thank our data providers. I highlighted here the agencies that are providing our key data sources that provide time series information, updated daily, weekly, and monthly. I also want to thank our partners. We work with a wide variety of groups in order to put all this together. And the work of these agencies especially is the only way we could possibly have put together this web application. If you're interested and want to learn more about it, our application program manager, Ken Pellman, is going to be in the Expo Center with a few other of our colleagues. He can show you a live demo of the application. And, or you could go to the website when you have a chance. If you're somewhat new to GIS, I do recommend taking a minute to take a tour and look at the story map. Those give you a nice introduction and a few tips on navigating the website, because we do call it a web GIS. It's pretty robust. And my name's Lisa Colson. I thank you for your time.
Hi, I'm Jim Hipple from Risk Management Agency in Farm Production and Conservation Organization. And for most people, Risk Management Agency, what's that? We are federal crop insurance. I'm going to talk a little bit about enhancing integrity in the crop insurance program through data mining and analytics. And first, I want to thank Shirley for inviting me to speak at this event. The RMA Business Analytics Division, I've been associated with it in whatever name it is now for about 16 years. We're kind of a little unique entity within Risk Management Agency, and our job is to provide information and products to our primarily compliance investigators, compliance division, to help identify waste, fraud, and abuse. We provide research, training, data, and in essence, platform resources for conducting advanced analytics in our program. We were put in place, and if you look at the language here, it's very similar to what was earlier presented for FSA in terms of directing agencies or risk management agency or farm service agency in looking at waste, fraud, and abuse in their program. We started through the Agricultural Risk Protection Act of 2000. So we've been doing this within our agency, analytics, data mining, for a little bit over 18, 19 years. Some of the areas that we focus on is prevention of waste, fraud, and abuse. Look at impact and influence of external factors. That could be weather and climate-related events that impact the crop. And so in essence, crop insurance, we're looking at insuring against weather and weather-related events as some of the primary causes of loss. So being able to take a crop insurance policy that has a loss due to some weather condition and looking at that and validating that cause of loss based upon weather and climatic information is important to us, but it's also important to us through analytics and data mining, not to just do that for one crop insurance policy or the number of crop insurance policies that our 60-plus compliance investigators can look at, but to do that for all 1.1 million crop insurance policies, of which maybe 30 or 40% of them may have a loss in a particular year. So going through and using the power of the information technology, the machine, to do the work and enhance the work that a particular compliance investigator can do. So they can just look at those that are an anomaly and not spend their time looking at all those that fall within some sort of a norm. One of the things that they directed us to do is, in essence, create a single data warehouse for our crop insurance information that is used in this analytics platform. Parts of our BI system and the way that we've been working this is we start out with system of record data, which most of the agencies work with. In our agency, it is the PASS system or policy acceptance system. There is something then, a level called the system of integration. That's our data mart infrastructure that's providing information out to support all the other business applications. And then what we have in the area that I work in is this system of analytics. And it is, in essence, taking all of that data plus other data and putting it in a fashion where the data structures are more readily used by the BI applications that we build upon it. We have in this our systems view here, where you have the past system, that's our system of record, that's the information that is coming in from what we call our AIPs, or approved insurance providers, and crop insurance is a public-private partnership where the delivery model is that the interface with the producers is actually through contracted insurance providers, where they have contract with the agents and the loss adjusters for delivery of the federal crop insurance program. And the government, in essence, acts as partly a reinsurer and partly a regulator in this process. Then we have the information system, the CRBI, and I have our little kitten up there, because sometimes the information in there or the data transformations in there are a little fuzzy. And knowing how that data is cleaned is sometimes you have to keep track of that. And I think what Ted Kalk talked about this morning in terms of putting in place processes and policies and procedures is important in these systems. And then we sit in this CAD environment, this bad CAD we call it, because we're business analytics. This is the system of analytics, where the data in here, we go through a big transformation and cleaning process. We make sure the data is clean, consistent, current, conformed, and comprehensive for all the data, and we build it around the idea that we insure land, so we should build up all this data for the crop insurance policy from the smallest resolution possible. And in that case, it's starting from the CLU, which builds to a crop insurance unit, which a number of crop insurance units are aggregated, and that becomes a policy. Then that becomes the county offerings, and that becomes the state, and that becomes national. So you could actually go into this, and everything is the ability to drill down into this to the smallest unit, and have that data ready to build the analytics applications on top of that, whether it's a geospatial view of the data or whether it's advanced modeling of some sort. So our system of analytics, we go through, and what we look at is that this is not necessarily the same as our system of record or our system of information. That we go through, we fix missing data. We look at outliers and remove those. We fix structural errors, the things that make the data and the database able to serve a variety of different applications, whether they're data science applications or whether they're reporting applications. Then we go through and build in and incorporate feature engineering into it. And one of the most important things in that is creating those functional linkages in the database from the very beginning between space and time. So rather than looking at a program from year to year to year, independent of itself, how do you track a farm? How do you track a field from one particular field through time, regardless of who owns that, regardless of who is farming on it in that particular year, whether it's fallow, whether it's corn, whether it's soybean, and look at that into the context of program integrity in relationship to the crop insurance program. One of the things in that building in geospatial information and the completeness of the data. Within RMA, we started about 2011 requiring location information of a good resolution integrated into our program. And that is, we started using the CLU for acreage reporting. And that information on how it comes in from RMA and how it comes in from Farm Service Agency, we do a lot of data cleaning, a lot of missing data fixing. From that, we go through and we've actually started implementing Tableau as a visualization layer or a visualization tier in our application, but being able to drill down to that most local level, the unit or the CLU within that. We also integrate things like creating dashboards that help us understand the situational context, whether it's looking at cause of loss and the impact of that on program delivery, and using analytics to help future decision making. Something simple as, in this case right here, the decision on earliest or final planting dates for a particular crop type practice, and looking at that in a spatial context and determine whether you have outliers. So in this case right here, just using very simple spatial statistics to be able to go in and do an analysis and identify where a regional office may have set a wrong planting date that then may affect the insurance outcomes in that, because the crop couldn't have made by planting by that final planting date because it puts it too far into the growing season. It starts being hit by end of year frost. So a program integrity problem potentially of our own making. And then taking all of that information and pushing it down to the local field level, in this case right here, looking at the individual producers or the individual fields in relationship to those peers. So a very spatial problem where you look at an individual producer, the individual field, and relating it to frequency of claims, severity of losses, and size of losses, where it's actually being able to highlight those that are anomalies from their particular local peer group. And then other tools of analysis. And one of the tools of analysis we have for our compliance investigators built upon this system of analytics is a link analysis, where they can go in and look at an individual producer, look at the relationships to the loss adjuster, to the agent, and then be able to push it through and compare it against how that policy does in relationship to other crop insurance policies or the county or a particular geographic region, and then push it down to the geography. So taking that and putting it into the locational context, and then being able to take that anomaly and look at it and help them prove or disprove whatever the allegations are in a web mapping application. Some of the other things we do as related to that planting date is actually taking the geospatial information and put it into context. In this case right here, an example of a decision support tool supporting the identification of planting dates based upon the programmatic history. In this case right here, looking at planting dates for a county, driven by the experience of that producer at a crop unit level, in essence, aggregated by its local neighborhood to determine whether the final planting date is correct, based upon program experience, whether it be average yield impact, whether it be the types of causes of loss that occur, and make this information available to our underwriting and regional program offices to help them pick the appropriate final planting date or early planting date for that particular crop and county. Other things that we do and is we build into this analytics system, trying to give you a broad spectrum of what we do, is things like, it was talked about at the beginning, validation of weather-related claims on a more automated basis. And this is some of the work that we've been doing in hail claims validation. So basically looking at a crop, the producer that has a hail claim, and looking at that in relationship to NOAA weather radar or other data, and not just doing that on a one-off basis, but this is actually ends up being a filter, as in essence an exclusion filter for putting that producer into other scenarios that we might be modeling. So if there's a valid hail claim, then we don't necessarily look at that. One of the things that, thinking about this in the context of analytics systems, one of the things that we've learned, we've been working on this for about 20 years, is that building, in essence, a spatially aware system of analytics is a big lift. That's my ending time. Spatially aware, it's better than my other ringtone. Building out a spatially aware system of analytics, it's a big lift. You have to really think of it from start. And, we've worked very hard, in essence, of building this system up from that lowest common denominator, that crop unit or that field, and really making it functional to build any other sort of analytics that we want off of it. Sometimes we separate out the spatial data from other data sets. So spatial data is different, but you lose a lot of power by not having those in the same system and those functional linkages built. And that's one of the things that we learned. Geospatial data is more complex, but it's still data. It's just complex data. You add a couple of dimensions to analysis. And everything that we're doing here is built around, we have to have an architecture that is robust enough to handle these data and complex relationships. And sometimes the things that we want to do aren't necessarily possible because we all have really good ideas, and we heard a lot of really good ideas today. It's that the infrastructure doesn't keep pace with the brilliant thoughts that we all have on the things that we want to do, and taking that data and making it information. That's all I got. Thank you.
There is an expo. We're actually a little ahead of time here. So there is an expo in the back of the cafeteria. We've got about 10 different agencies and tables set up there. I really encourage you to go back and talk to folks. We have one of our folks from Fort Collins that's on the cloud services. She's got a table set up. Esri actually has a table set up as well. And if there's people that want to talk to somebody about the ELA or talk to someone about solutions, our Esri folks are at that table, can help with that. And then I want to encourage you all to come back at 1 o'clock. We've got a very engaging keynote speaker at 1 o'clock, and then the afternoon we'll have more presentations, panelists, and it should be really exciting. So please come back and enjoy your lunch, and we'll see you shortly before 1, hopefully. Thank you.
Yeah, I just asked Shirley. She said it'd be fine. Did you bring your laptop? It's horrible here. Even with your dongle? Yeah, it's slow and. Whoa.